All right, it doesn't look like we have any live participants this morning, so we're going to go ahead and get started with the recording. I'm Bradley Stevens, a senior client network engineer working for MCNC's client network engineering team. And this summer webinar series session is actually going to cover Rancid, which is an acronym for Really Awesome New Cisco Config Differ. So it has a funny name, but it really is a really awesome tool. So to go on ahead and get started, let's go over the agenda for today's session. I'm going to provide an overview of Rancid, detailing the different aspects of what's going on in the background and foreground, as well as how you interact with it through VVC. I'm going to go over some common methods for obtaining and installing Rancid. And we're going to have two demos. The first is going to cover configuring Rancid to actually go out and pull your device configurations and back them up so you can have them for archiving or for diffing later on. And then the second demo is going to cover using ViewVC so you can actually log in to the browser interface and take a look at diffing your different revisions of the configurations as they change through time. And then we're going to wrap things up with a Q&A. So to go on ahead and kick it off, just to provide an overview of Rancid, as I mentioned before, it's an acronym for a really awesome new Cisco config differ. And it's pretty self-explanatory as far as the purpose of the tool. It's an open source tool to help you archive your device configurations and perform diffs on them later on. Rancid supports primarily Cisco devices, but it does also support other vendors as well. Personally, in the past, I've had success with running it against HP devices. Although if you do have a non-standard vendor, you're likely to run into some quirks with the scripts when it goes out to pull your device configurations. So in the background, sort of under the hood, so to speak, Rancid is using CVS, or the concurrent version system, to create repositories on the back end to store the configuration data and provide revision control and analysis like diff functionality as far as emailing those diffs or passing them up to VVC for the browser interface. So just to continue on, a little bit more of the innards of how Rancid works. It utilizes expect scripts to log into each device that you've got configured in the router.db configuration files. Then it's going to perform a couple of actions. It's going to start by running commands to obtain information. So the commands that are typically configured to run against, for instance, a Cisco device would be show inventory, show run, show flash, and a few other things. Those are configurable, so if you wanted the output of an additional command that's not ran by default, you could configure it to do that. Afterwards, after it has that output, it's actually going to reformat it such that any oscillating or incrementing data or things that would change throughout time are going to be stripped. And that's to prevent flooding different revisions in your CVS repository so that every time Rancid runs, you don't have a new revision for that device. And then it's going to finish up by emailing the differences from the previous revision for all those devices and then committing the changes to the CVS repository. And with email, that's one of those things to where you have to have a little bit of additional configuration, and it's a little bit outside of the scope of what we have configured today in the lab environment, but it's very easy to configure the aliases to set the email addresses to actually get it to go through there. The deeper part of that is to configure the system that Rancid is running on to be able to properly forward email messages using SendMail. So then we actually go to the next step in the chain, which is where we add ViewVC into the mix. And ViewVC is a browser interface that talks to the CVS system in the back end to be able to browse and display the CVS repositories that Rancid creates and maintains. So ViewVC is sort of your eye into the repositories that are maintained by Rancid, so you can actually look at your device configurations and perform the diffs that I was talking about earlier. Later on in the session, we're going to have the full demo that shows both configuration of Rancid and actually using ViewVC. So if you're not familiar with these tools, you'll definitely get a chance to see them in action. VVC has a directory browser to allow access to every group of devices that you've configured in Rancid. So the basic way that works, you could separate your Rancid groups by your different sites or your different schools, whatever's applicable, and then create sort of an organizational hierarchy for how you have your devices listed in Rancid, as well as displayed in VVC. And then VVC also, as I've mentioned a couple times now, provides that capability to diff two of the revisions in the CVS for a given device. And the cool thing is that it has the capability to do that diff in color, where additions are colored in green, changes are colored in yellow, and deletions are colored in red. So moving on, some common ways that you would obtain or install Rancid. Probably the preferred method, at least to try the tool out and to see if it would meet your needs, would be to download the Client Network Engineering team's Network Monitoring Probe Virtual Appliance, because that virtual appliance actually includes a pre-configured copy of Rancid and VVC, so that we've already done all the initial legwork to set that up for you. Basically, all you have to do at that point is configure Rancid as per the demo that we're about to move on into, to have your credentials to log into the devices, as well as the actual definitions in the configuration for the devices themselves, be that a fully qualified name or an IP address. You always have the option to go out and grab the sources for Rancid or VVC and build them and install them. That's really kind of outside the scope of this session. There are definitely guides that are available on the internet for lots of different platforms and operating systems, depending on what you're running, as far as getting it to build and install on your platform. And there may actually be packages available, either as a source package or a binary package for your operating system. Typically what we see with that is Rancid tends to have more packages built. In comparison, since VVC is essentially just the browser interface, you may actually have trouble finding that in a repository or as a source or binary package and have to install that manually on top of Rancid. So with that, we're going to go on ahead and move into our first demo, which covers the Rancid configuration. So if you'll give me just a moment, I'll share my screen and we'll go on ahead and start the demo. All right, so I've already got VVC open in the background, but we're going to save that for the second demo. We'll go on ahead and start with the first, which is actually configuring Rancid. So as far as the initial configuration of Rancid, as I mentioned, the preferred method is to download the probe virtual image, because it already has Rancid and VVC pre-installed and some of the configuration already done. So the terminal that we're looking at here is actually a running copy of that probe virtual appliance, and I'm actually logged in as the Rancid user, as you can see there. So basically, from the point of deploying the virtual appliance, if you were going to configure Rancid for testing or for use, all you would have to do is elevate to the Rancid user from root by doing superuser space hyphen space Rancid, which will log you in as the Rancid user. One of the things with the way that Rancid operates is that it actually runs all of its scripts and operations as the Rancid user. So it's very important anytime you're configuring Rancid or manually running any of the processes that you're logged in as Rancid prior to doing that. So to go on ahead and start it off, I mentioned that there was already pre-existing configuration here. To show you the structure of the configuration directory, I'm just going to list this working directory. So the way that this is installed with the CentOS package we used for the virtual appliance, it replicates some of the directory structure in that you have the etc directory available. So your main configuration file is going to be in the Rancid's home directory and then /etc from there. And then you're actually going to be editing the rancid.conf file. That's your main Rancid configuration file. So a quick overview of this file. Most of this is default as it came from the package. and there's not really a need to change very much, simply for the fact that most every one of these parameters is either set properly already by the package or because the defaults are acceptable. What you're going to primarily be interested in is defining your list of Rancid groups. So as I was mentioning before, Rancid divides your devices into groups, and for each group that you define in the configuration file here, a different CVS repository gets created. So you can see that for the lab session today, I've actually already defined quite a few different groups. We have lab core, lab site A, and then that continues all the way through lab site E. So after you go through and set the group names per whatever works best for your environment, you're going to just save this configuration file. In this case, I made no changes, so I don't have to confirm. And then you're going to run the utility called rancid-cvs. And that will actually run through, pull the groups from the configuration file and create the different repositories that you need to hold your different organizations of devices. More often than not, what I would see is folks would create different groups for different sites. So if you're only a single organization running Rancid, you may want to have a group per site or a group per school. So if you have 10 switches at a given school, it may make sense to give that school its own group just for organization's sake, and you'll be able to see that much more clearly whenever we move on to the demo of UVC. Just a quick glance, you can actually see that the group names that I created in the configuration file are immediately shown in UVC and are browsable there right behind the terminal window. So since I've already set up the CVS structure, I'm not going to run this command right now. But after you ran that command, it would go through, create the initial repositories, and create your router.db configuration files. We'll move on to that step here in just a moment, but the next step to configure Rancid is to actually define your credentials to go out and log into the devices. So as I was mentioning before, Rancid essentially uses expect scripts to be able to log into your devices with Telnet or SSH. We never really recommend that you use Telnet in production, simply for the fact that it's clear text. So obviously we prefer to use SSH to log into the devices. The other huge caveat with Rancid is that you should definitely be using a dedicated user account for this, simply for this fact. If you're going in to set your credentials, those are actually contained within a single file. So if I go into edit the file called cloginrc, that doesn't exist because I misspelled it. There we go. All right, so the cloginrc file is hidden, and it can only be read by the Rancid user. That's another reason why you would want to be logged in as Rancid here. But the big caveat why you would want a dedicated user account for your switches, either in TACACS or if you go through locally and define the user accounts, is that setting the passwords for Rancid is actually on the you take steps account simply of a network access username and password for the management interface to your switches. Here, I'm actually going to scroll down such that my lab credentials are set at the top of the page. There we go. So you can this block here. I'll highlight it for you. And take our comes to define specific credentials, we begin and credentials for some of my lab subnets there. Quick description of this syntax. If you say add password, that's for the original line-based password method. Then you could do this. So you would say add password, and then you would 10.132.0.0/24 is the wildcard character right there. And the first password is, and then the second password is, look up here in the default syntax for this word. It gives you an example. The next thing that you could do is you could set a method. As I mentioned, we never really suggest defining using telnet. Same thing goes here. Defining the method, we define telnet to be for all of 10.132.0.0/24 as well. That's in this subnet is going to use this method, and it's going to use this. Further on, you can see the actual user account for a specific device, just to show you how that can be done. And you can actually address that. In a particular case, I'm adding a user account for Rancid for this one specific switch, 192.168.0.2, and the name of the user account is Rancid. Further down, include everything. So you can see that I'm adding a password for anything in 192.168.0.0/24. The line password go, and then the enable password once again go. Further on, for the specific device page, we actually have called auto enable. So if you're using the old model for directly to an enable Rancid so that it knows what to expect. Upon that, you're telling it for this one specific device, 192.168.0.2, upon us moving further down, device 192.168.0.2, again, we're actually SSH, and then for all, save this file. I'm just going to show you the permissions on it really quick, so you can see that particular case. Actually, read that file. So the next step would, so after you've put your credentials into this Rancid and its spec scripts that we log in. Then you specify device. In case I already have a virtual lab running in Cisco's new simulation tool and one core router. So they're a small version of what you may be, but their IP addresses are 1.0.1. So if we want to test one of those devices, we can actually type. So if we logged into the core device that I just read the IP address for, you can actually see that scripts actually go through and interactive prompt. So at this point, just as if I were logged into it directly. So you can see that, and then you can exit it out. That proves the need for security, because to the Rancid user on this devices with an enable privilege or security. Further, the specific device then was using Telnet for the lab, but if I log into 0.2, that actually uses SSH. So you can see that here we're actually prompt. So you can see that here. So after you've gone through, the next thing that you're going to want to do in Rancid manually for the first time, Rancid-run. And once you show run of the presentation, a little bit early lab, and since they're a little bit slower than production devices, the PowerPoint slide. So let me stop sharing my desktop and share the PowerPoint slide. So that's an overview that you would go through to configure Rancid to actually go out and talk to your devices and pull the configurations. Moving forward a little bit, there are some advanced options to make that process a little bit easier. So if you are versed with Linux command line tools, you can use utilities like nmap, grep, and awk to sort of create a little bit of automation for this task. So the overview of how this would work is that you would scan the target subnet where your switch management IP addresses are with nmap for devices that answer or are running SNMP servers. That way you can verify that you're indeed talking to a switch and not some other device. Then you take the output of that nmap report and filter it to just the IP addresses with grep, and then use awk to actually reformat those IP addresses into the rancid router.db syntax. And I actually realized with that rancid run that we actually need to take a look at the router.db. So let me hop back over, share my screen. So you can see that rancid run actually completed there. Let me hop back in here to this directory structure. So after you've defined your credentials and tested them, the next thing that you have to do to configure, sorry for the oversight, is to actually change directory to the var directory. And then you can see that you have directories for each of the groups that you created. In this particular case, we don't have a definition for site E, so I'm going to go ahead and create that. So if we change directory into lab site E, we can actually take a look here and see that we have a couple of different files in here. The configs and CVS are where Rancid will actually store the device configuration. The file that we're primarily interested in for making edits to is router.db. So if we actually edit router.db, the syntax to define a device is its IP address or fully qualified name. So in this case, we're doing site E, and his IP address is 192.168.0.2. Then we use semicolons to delimit it. We tell it what kind of device it is. So in this case, it's a Cisco device. And then we tell it what its operational status is, either up or down. And in this case, we want to define it as up. So after we've made this definition, we've told it what IP address of the device to look out and go out and pull configs from. We've told it what type of device it is, and we've told it that it's operationally up or in production. It's actually going to use this IP address against the credentials file that I was showing you earlier to be able to know how to log into that device and to be able to pull its configurations. So after we save the router.db, then we want to go back up to the home directory of Rancid and run rancid-run. So without getting ahead of myself, now that we've made the definition for the device in site E, it will actually go out and log into that device with SSH to pull its configuration. So you can actually see that prior to this running, in ViewVC, we have no entries in the router.db for site E. After it goes through and finishes, we'll be able to see that we do have files in site E. So now actually completed that to run, I'll go back to my example of the advanced configuration to automate that task. So back to the overview of the way that this would work. You scan the subnet that you're looking to add devices from with Nmap, and that's to determine which of the devices are running SNMP servers to help clue you into which of them are switches versus which of them are servers. Because you could very well have just a regular server that runs SSH, but if you're running SSH or Telnet and SNMP, then chances are that's probably a switch or a router. Moving further down into the process, like I said, we actually use grep to filter the output of that Nmap report so that we only have the IP addresses of active switches with SNMP servers running. Then we use awk to reformat the addresses into the Rancid router.db syntax. So now that we've just completed that step, this will make a little bit more sense. These are the actual steps to do this, so you could use these commands to actually go out, perform an SNMP scan of the subnet. That's the first bullet here. So let me see, I should be able to draw a rectangle around that. Yeah. So the first step here is actually going to use Nmap to go out to a target subnet and scan it for SNMP. The elements of this, you can see that the SU flag means that we're doing a UDP scan. We're telling it that it's port 161, which is the port for SNMP. The way that we can actually tell that we're looking at switches is by running the script or plugin for Nmap called snmp-sysdescr for system description. For that script, we have to provide the community string that you use on your network. So you can see that we're defining that with the script args snmp community equals and then your actual community string. In this particular case, the example community string that I'm using is lab-snmp. The next element is the target subnet that you want to scan. So in this particular case, I'm scanning 192.168.0.0/24. And then I'm taking all the output from this command as it runs and redirecting it to a text file called raw scan.txt. And I'm actually putting that under the Rancid directory structure. The next thing that you would do is to actually log in as Rancid. So I've shown you that before in the terminal. Then what we want to do is to actually use grep to filter out the results from that scan so that it's just IP addresses. So cat prints the contents of that text file, grep filters it, and then next we actually use awk to go through and strip out just the contents of the IP addresses. The way that the output actually works is that in column 6 in the file, that's where the IP address is, so that's what the awk print 5 does. Then we're actually directing that output to scan IPs. So in this scan IPs.txt file, you should have just a list of your switch IP addresses that you discovered using Nmap. You can see from there, we proceed to print that scan IPs.txt file into the router.db file. And then we actually use sed, which is another Linux command, to actually change the IP address into Rancid configuration syntax. So you can see that we're taking the actual IP address, which will be represented by the $sign there, and then adding Cisco and up to the end of each line, which completes our Rancid syntax. Then we're moving our files around such that the router.db file actually contains the full syntax. And then we do a manual Rancid run and detach it from the terminal. So if you're familiar with Linux, that would be a good way to go through and discover all the switches on a given subnet and have an automated way to add them in. So now that I've provided an overview of configuring Rancid, as far as getting your devices in, setting your credentials, and then some advanced ways to automate that process, I want to go through and actually show some of the use of this. So with that, we move on to our next demo, which is using Rancid together with the tool called ViewVC, which, as I mentioned earlier, is the browser interface to the CVS repositories that get created. So now we can move back over since Rancid run has completed in our terminal, we can actually move on over to ViewVC. So a good demonstration would be to actually look at site E. So you can see that prior we didn't have any entries in our router.db file. Now, since we've made this update, we can see our change to include 192.168.0.2 in the configuration definition. And then since we did that, it actually went out and logged into the device and pulled its configuration. So you can see that we're no longer at revision 1.1, which would be the initial revision whenever you created the repository. And revision 1.2 is the initial configuration. So you can see that between revision 1.1 and 1.2, we added 223 lines, which is essentially the whole content of the configuration. And this is where the benefit of using Rancid and using ViewVC comes in. So after you've used these tools and configured them to go out and pull your configs, you can view them in ViewVC as the web interface here. So as I mentioned before, a few different commands are actually ran on the devices. So we actually start with some general information about the device from a show version. So you can see that the different type of chassis, the memory statistics, as well as the serial number. Then we actually show the contents of flash. So you can actually see the files that are on flash on that particular device. And then we actually go through and have some show inventory information that's printed next. So for these virtual routers, this information is not very interesting, simply for the fact that these commands don't really print out all that much. But a good example or use case of this for a production device would be that if you were trying to keep track of the serial numbers of SFPs that you have plugged into your switches, all of that shows up in a show inventory. And now Rancid is periodically logging into your switches to pull that information down. So you can actually see through time, anytime an optic changes in your switch, because its serial number would change in that particular slot. So that's another good use case for using Rancid in production. Then we actually run the configuration information. So we actually have the configuration register that's active, followed by the running configuration. And you can see that this is just a very simple lab configuration that was generated by the Cisco simulation tool. So you can actually see all the different config elements that are there, and this is verbatim a copy of the config that's running on that device. So viewing the configurations is obviously very beneficial, but where you really start to run into some of the power of using Rancid and using VVC is when you want to see how things change over time when you archive your configs. So you can actually go back to the root of the tree and view a device that I've had in here longer and see that I actually have more revisions here. So for the core device in the topology that I was showing you earlier, I've had it added to Rancid for much longer. If we hop back over to Rancid, you can actually see that instead of only having 2 revisions, .2, I have 4 here. So if we look at this, we can actually see the most current revision, which is 1.4. So this is the actual most current copy of the config and commands that were pulled from the device as we saw earlier. But then we can actually go into the revision log. And this is where the real power comes in of these tools. So you can, and then not only can you see when changes were made, it's those changes. So I can actually diff 1.4 and 1.3 to see what changed. So here you can actually see that I was enabling SSH on this device. Line 113, we have an addition, which was the IP. Then moving further back, if we go to the revision log, you can actually select the newest one for diffs, and then you can go back to a previous revision beyond that and diff to the one that you've selected. So instead of clicking diff to previous, I'm going to go to revision 1.2 and diff it to selected 1.4. So with this, you can see that I've changed on this device since I Rancid. In this particular case, you can see my change from revision 1, and then you can also see that earlier on I added, so you can definitely see that there. The other thing that you can do as well is show the annotations. So if you click show annotations for a specific device, it shows you the whole config, and if you're familiar with revision control systems, this would essentially be which lines and do that there. Since Rancid is the only user that's actually going out to pull these configs, user here, but knowing when it changed will serve quite a bit of benefit there. So in this particular case, you can see that the lines that I changed here, IP domain name lab.net was made in revision 1.4. And then if you look at the OSPF configuration change that I made, you can see that that was made in 1.3. At a glance, if you want to click through on that, you can click that link and that's similar with all the other devices as well. So in addition to core device, I've got devices at other sites as well. Then if you look at these guys, you can also view the most current configuration very similarly, and then you have the same capability to view the revision log changes through time, as well as the annotations for the lines of the configuration. That's a very similar aspect here. So to go on ahead and kind of wrap this demo up, the other thing that I wanted to do, email to being able to manually go in different these diffs to that into your aliases file on the I actually need to name it that because that's a file. The gist of it is that you need to create an alias for an email address for your Rancid group name. And in this particular case, I don't act, but it would be as simple as lab core, so your actual Rancid group name, and then an email address. Then after this, Rancid will know base 2, and then if you've configured changes in each revision. And if you need more information on that, there are guides online that will help you with configuring all of that. So moving on, since we don't have any live participants, we really don't have the opportunity for a question and answer session. So I'm actually going to pop on back through here to my contact information. So as always with network monitoring tools, it's definitely a case of your mileage may vary depending upon your needs and your requirements. So one of the things to consider when you're wanting to deploy Rancid on your network, if you're wanting to do it more than just testing and actually put it in production, it's definitely the case that you need to consider the sizing. So Rancid operating against 50 devices looks much different than Rancid operating against 500 devices. And the actual runtime of the commands to pull your configs is going to be vastly different. So one of the things that you'll have to do is just consider those caveats of how many devices that you want to track with Rancid, and then make sure that you size the hardware appropriately, or maybe even split the collection tasks to multiple Rancid servers, such that you're not overloading a single one. The other thing as well is if you run into any issues or if you're interested in deploying this in production, the client network engineering team is always happy to assist with projects that assist you with your network monitoring like that. So for Rancid, feel free to send me an email. And you can also view the contents of this webinar in the archive section there. Obviously, if you're viewing this recording, you already know how to do that, but we'll be more than happy to help. So with that said, I think that just about wraps everything up.